Uh, Good day, everyone. We are about to start our live class now, which is possible examination question on CHM 101. Okay, I'm just trying to confirm if we are all live. Okay, the sound is working. Okay, the sound is working. Okay. Please, you can invite your friends so that we can start the class immediately. Once we are up to 10, once you are up to 10, then I'll start the class immediately. Please make sure you share the video to others. I have over 100 questions here that I'm going to explain in this our live class. Possible examination question on CHM 101, the Gido approach to chemistry. So let's keep it going. Remaining one more person before we start the class officially. Okay, please share the link to others. Share the link to others. And you can repost on your status. Please post in the group chat. Okay, we are already up to 23. So let's start the class properly. Now, if you have any question at all, you can ask your question. I have a live chat here, so I can easily read your question and then tell you the correct answer. Wherever you are confused, please feel free to ask all your questions. Feel free to ask all questions, then I will gladly answer. So we have about 10 topics here, and I'm going to pick the topic one after the other. So the first question here says, question number 1, the word thermodynamics is derived from the Greek word meaning heat and energy respectively. I repeat, the word thermodynamics is derived from the Greek word meaning heat and energy respectively. Option A, we have thermo and dynamic. Option B, we have thermo and dynamo. Please, CHM 101. Now, the word thermodynamics actually got it from two Greek words. We have the word thermo and what? Dynamics. But the Greek words are thermo and what? Dynamo. Whereby thermo means what? Heat, and dynamo means what? Change. So if you see a question like this in your exam, the correct answer is thermo and what? And dynamo. And thermo means heat, while dynamo means what? Change. Question number 2 says, classical thermodynamics deals with the property of matter in dash. Now, there are two types of thermodynamics. We have the classical thermodynamics or the classical thermodynamics, and we have the statistical what? Thermodynamics. The question here says, classical thermodynamics deals with the properties of matter in dash. Please, it deals with the property of matter in bulk. If you don't see the word bulk in your option, you see something like macroscopic. So is it that you see the word bulk or you see what? Macroscopic, because classical thermodynamics explain the macroscopic portion of what? Of matter. Why statistical thermodynamics explain the microscopic. So please, in your exam, if you hear the word macro, is classical. If you hear the word bulk, is classical. If you hear the word micro, is what? Statistical. Then the next one here says, the change in entropy of a system is expressed as dash. Is expressed as dash. There are different options here, but I don't want to go through the option. But if you say a question, the change in entropy of a system, please, delta S, if you have anything like S, it is wrong, because you're talking about change in entropy. So delta S is equal to what? S2 minus what? Minus S1. Or delta E is equal to EP minus what? ER. Or delta S is equal to SP minus what? Minus SR. So if you see any of the three, is correct. But if you see S1 minus S2 is wrong, because you have to take the product first before the what? The reactant. So entropy is more of the degree of disorderliness or randomness of a system. And it is usually between the product and the what? And that of the reactant. And another thing again I want you to take note of there is that which is called enthalpy. If you are talking about enthalpy, enthalpy is the same thing as delta H of the product minus delta H of the what? Of the reactant. Enthalpy is talking about heat content. Entropy is talking about degree of disorderliness, while enthalpy is talking about what? The heat content. So if you are talking about the heat content, this is the formula you use. If you are talking about the entropy, you can use formula 1, you can use formula 2, you can use what? Formula 3. Then another thing again I want you to take note of here They said du is equals to dq minus dw. So du is equals to dq minus what? Minus dw. Thank God there is light. Let me just turn off some stuff. Don't worry, let me just continue with the class like that. Now, this is the kind of calculations we have. du is talking about internal energy. dq is talking about heat. dq can be positive and can as well be negative. I repeat, dq can be positive and can as well be what? Be negative. dq can only be positive. dq can only be positive if the reaction is what? Endo. So for an endothermic reaction, that means the system absorbs heat, then du is what? Is positive. But if du is negative, that means the system does what? Give off heat. Absorb positive, give off heat is what? Is negative. So in the formula. Then another thing again, I'm going to take note of, a system can be performing work, and the work can also be done on the system. If the work is done on the surrounding, that means you use this value. And if the work, for example, let's say this is surrounding, this is system. If the work is done on the surrounding, that means the work is done by the system. If the work is done on this board, that means the work is done by who? By me. And we're writing on the board. And if the work is done by the board, that means the work is done on me. Do you understand me? So if the work is done, if the work is done on the system, which is the work is done on the surrounding, which is by the system performs work on the surrounding. System perform work on the surrounding, it is negative. But if the surrounding perform work on the system, here will be what? Here will be positive. So that's something I want you to take note of. If the system performs work on the surrounding, negative. If the surrounding performs work on the system, is what? Is positive. So that is for that. Then the next question here is that number 7. A reaction is spontaneous. A reaction is spontaneous when delta G. Now, delta G is known as the Gibbs free energy or the free energy. Now, delta G can be greater than 0, delta G can be less than 0, and delta G can be equal to what? To 0. Now, they said if delta G is greater than 0, please take note, the reaction is non-spontaneous. If delta G is less than 0, the reaction is what? Is spontaneous. While if delta G is equal to 0, the reaction is at what? Equilibrium. So in your exam, you might see something like this, but take note, if delta G is greater than 0, it is not spontaneous. That means the reaction is irreversible. If we have a delta G less than 0, that means the reaction is what? Is spontaneous. That means the reaction can occur on its own. Then if the reaction is at equilibrium, which is the reaction is reversible, so it can go forward, it can as well do what? Come backward. So please take note of that. Then in a case like this, delta G is equal to 0, the reaction is said to be what? Equilibrium. But equilibrium is not in the option. Option A, what you have here is spontaneous. Option B, what you have here is non-spontaneous. Option C, what you have here is endothermic. And option D, what you have here is what? Reversible. So from what I've already explained, if the reaction is at equilibrium, that means the reaction is what? Is reversible. So option D will be the correct answer. The next question here says, the Gibbs free energy is defined as, the Gibbs free energy is defined as, please, is defined as G is equal to H minus Ts. Gibbs free energy is defined as what? G equals to H minus Ts. Then if they ask you, what about the change in Gibbs free energy? If you are asked, what of the change in Gibbs free energy? The change in Gibbs free energy is not this again. What you write, this is defined as this, but the change is delta G is equal to delta H minus what? T delta S. So we have delta G minus delta G is equal to delta H minus T delta what? Delta S. So that's on that thing again I want you to take note of. Then the last question here for the thermodynamics before we move on to other concepts. I skipped one, please. Which of the following is an extensive property? Which of the following is an intensive property? Which of the following is an intensive property? Now, intensive property, they are independent, while extensive property, they are dependent on the magnitude of the material. So if the property of the system is independent, please take note. We have intensive, we have extensive. Intensive is talking about independent, while extensive is talking about what? Dependent. So intensive, independent, extensive is what? So just in case you forget your exam, intensive, independent, extensive is what? Is dependent. Now, as long as the extensive property, they are dependent on the magnitude of the material, and intensive, they are intensive, independent, extensive are what? Are dependent. Example of extensive are VM. This is what I call VM. VEIEM. V stands for volume. I stand for, in your exam, these are the only one they will give to you. Internal energy. E stand for entropy. And M stand for what? For mass. These are the only ones they will give to you. Volume, internal energy, entropy, and mass. These are what? Extensive property. So that means they are dependent on the magnitude of the material. Now, let me give you the question. Which of the following is an intensive property? That means which of the following is independent of the magnitude of the material? Option A, mass. Option B, volume. Option C, temperature. Option D, entropy. If you look at it, we have mass, we have volume, we have temperature, and we have entropy. So is temperature here? No. So that means temperature is an intensive what? Property. In your DELSU exam, these are the only four they will give to you. Volume, intensive, which is VM, volume, internal energy, entropy, and what? And mass. Then the last question here says, the first law of thermodynamics is also known as what? The law of conservation of what? Of energy, which is the same thing as du is equal to dq minus what? Minus dw. It's also the same thing as w is equal to minus p dv. Also the same thing with that. That's actually for the first law of what? Of thermodynamics. But before we move to the next concept, I really want to explain something real quick. There is that which is called a state function and path function. I repeat, we have a state function and we have the what? The path function. What's the difference between a state function and a path function? Now, a state function has an initial and final. So anything you can think of that has initial and final, like look at this one now, delta G. If you have delta G, it means change in G. That means there was an initial and there is a final. For example, delta H, I said delta H is equal to H of the product and H of the reactant. So there is an initial and there is a final. Look at this. If you look at this T here, there's no initial, temperature here is constant here. Delta S, there is an initial, there is what? A final. Now, I want to ask you, have you seen anything like T2 minus T1, initial temperature, final temperature? Have you seen? Yes, in Boyle's law, we have V1, V2. Sorry, in Charles' law, we have V1, T1, and we have T2. Have you seen something like V1 and V2? Yes, initial and final, that's volume for Boyle's law. Have you seen something like P1 and P2? Yes, that's for Boyle's law. Have you seen something like W1 and W2, which is work? No, you can't see anything like that. What about Q1 and Q2? No, please take note. Heat, and work, they are path function. Why any other thing that you can think of that have, like we have initial velocity, final velocity, initial volume, final volume, initial enthalpy, which is energy enthalpy of the whatever, and final enthalpy. Initial this, initial that. They are what? State function. But if you can't think of the initial and final, they are called what? Path function. Let's move to the next concept. The next concept here is properties of gases. The next concept here is properties of gases. This light. The next concept we have here is what? Is properties of gases. Now, let's quickly, if you have any question, please. Okay. Please, if you have any, let me check the quality of the video. I feel like the quality is okay. So, okay, I'm too fast. Jesus. Okay, I'll try to be slow. The light minister. It's leopard light. Leopard light is misbehaving. Part of the board. Okay. I will try. Please, I will share your comment and I'll work on that. I was trying to be very fast so that I can cover everything I have here. Now, question 11 here says, gas law are mainly used to dash. Gas law are mainly used to dash. Please, gas law explains gas behavior completely, option A. B, gas law predicts how gases behave under usual conditions. That's the answer. Bam. Now, gas law does not explain behavior of gases. Gas law only predicts how gases behave under usual conditions. That's why I can tell you that if the pressure of the gas increases, the volume will decrease. If the volume of the gas increases, the temperature will increase. That's for Boyle's law and Sharp's law. So you can only predict. You don't really explain the behavior of gases. So that's for that. Then Boyle's law describes the relationship between dash and dash. Please, Boyle's law shows the relationship between pressure and volume. Sharp's law shows the relationship between volume and temperature. Avogadro shows the relationship between volume and number of mole. And when you add Boyle's law and Sharp's law, we are going to have general gas equation, which is combination of pressure, volume, and what? And temperature. If you add these three together, you are going to have what? ID gas, which is combination of pressure, volume, number of mole, and what? And temperature. Which is that one again? Let's work with this five. Boyle's law shows the relationship between pressure and volume. Sharp's law shows the relationship between volume and temperature. Avogadro shows the relationship between volume and number of mole. While the combination of Boyle's law and Sharp's law is this, combination of these three laws is what? Is ideal gas law. Now, a question will come like this in your exam. A gas that behaves ideally at all temperature and pressure is called dash. The answer is what? Ideal gas. On that question again, if PV all over RT is equal to 1, what kind of gas is that? Ideal gas. If you increase the temperature and the number of mole remains the same, what kind of gas is that? Ideal gas. Because an ideal gas, if you increase the temperature, decrease the temperature, increase the pressure, decrease it, it has no effect on it. So that is what? An ideal gas. Any other gas you can think of, they are real gases. So let's skip that. The combination of Boyle's law, Sharp's law, and Avogadro explains that. So Boyle's law, Sharp's law, and Avogadro's law will give you what? An ideal gas. But Boyle's law and Sharp's law will give you what? General gas equation. Now, let me show you this. This is an inverse variation, and this is a what? A direct variation. Now, an inverse variation means if the pressure of the gas increases, the volume will do what? Will decreases. And for a direct, which is if the pressure of the gas decreases, the volume will do what? Will increase. That is for what? For Boyle's law. Because we are talking about inverse variation. While for a direct variation, if the volume of the gas increases, the temperature will do what? Will increase. And the temperatures must be what? In Kelvin, because we are talking about absolute temperature. So Boyle's law is talking about direct. Sorry, Boyle's law is talking about inverse. If one of them increase, the other one will decrease. While for Sharp's law is talking about what? Direct. God. Okay, let me be slow. Now, while Sharp's law is talking about direct, if one of them increase, the other one will as well do what? Will increase. So now let me show you an example. For example, if the initial P1, we have P1, here is P2, here is 1 atm, here is unknown, then V1 is 200 centimeter cube, and V2 is what? Let's say it is 400 centimeter cube. Now, I told you already. Let me change this value to 100 centimeter cube. Now, I told you already. If you look at this place here, from V1 to V2, is it increasing or it is decreasing? If you are moving from V1 to V2, you realize that it is what? It is increasing. Sorry, it is decreasing. From 200 to 100, you are what? You are decreasing. So if it is decreasing, the pressure will do what? Will increase. From 200 to 100, that means you decrease it by what? By half. You decrease it by, which is by 2. 200 divided by 2, you got 100. So this value here, instead of you to divide it, you now multiply it by 2. So 1 times 2 will give us what? 2 atm. If you divide this value by 2 to give you this value, then you multiply this side by 2 to give you this value. Now, let me assume that this one is not there. So I have P1, V1 is equal to what? P2, V2. What is our P1? 1 times V1, 200 is equal to what's my P2? P2 times 100. Let's divide both sides by what? By 100. 0 cancel 0, 0 cancel 0. What are you left with? 1 times 2. P2 is equal to what? 280. As easy as that. So most of the time in your exam, you don't really need to solve. You don't even need to solve, just for you to look at it and you're able to tell the answer if it is decreasing or what, or increasing. Then for Charles law, if one of them increases, the other one will do what? Will increase. Now, let's say here is volume is 1 liter, the other volume is 2 liter. Then here is let's say 27 degrees Celsius. Here is V1, here is V2, here is T1, here is what? T2. So if this value increases by 2, this value, because the direct variation, is also going to what? Increase by 2. So you are going to multiply this value by what? By 2, which you are going to get, here is 4, 2 times 2 times 2, which is 54. So if you have 54 degrees Celsius and you think that your answer is correct, that's very, very bad of you. It is not correct, because degrees Celsius is not the absolute temperature. You have to convert this to what? To Kelvin, which is 27 degrees Celsius plus 273, which is going to give us 300 Kelvin. So the answer will be what? 300 times 2 to give us, because this one is by times 2. So 300 times 2 will give us what? 600 Kelvin. So that will be your answer, instead of you writing 54 degrees Celsius. Please don't solve in Celsius. Make sure you solve in what? In Kelvin. So Boyle's law, another thing again is that you notice Boyle's law is inversely proportional to what? To pressure, or pressure is inversely proportional to what? To volume. So you say P is equal to K all over what? V. Then we say PV is equal to what? K. This constant in Boyle's law differs from the constant in Charles' law, differs from the constant in Avogadro's law, differs from the constant in Gay-Lussac's law. Now, in your exam, a question like this might be asked. A question like this, I believe that the lightning is okay. Increase your brightness. You see, the lightning is okay. I believe the lightness is okay. Okay, the lightning is okay. Please, if you have any complaint, you can drop it here. I'm going to attend to all your complaints, and I will try to be very, very slow. Now, the constant for Boyle's law differs from the constant for Charles' law, differs from the constant for Avogadro. Now, the constant for Boyle's law is what? Is joules. The constant for Charles' law is meter cube per Kelvin, while the constant for Avogadro is meter cube per what? Per mole. So if any of these questions come out to your exam, most cases they always work with B and C. The level answer of A, Avogadro. So which of them is the constant for Boyle's law? Is what? Joule. Constant for Charles' law, meter cube per what? Per Kelvin. So that's something I want you to take note of. Then an ideal gas equation is written as, please, an ideal gas is PV equals to what? nRT. PV is equals to what? nRT. And the value of R, which is the universal gas constant, is 0.0821 atm dm cube per mole per what? Per Kelvin. So that is the value for, whereby P is pressure, V is volume, N is number of mole, T is temperature, and R is universal gas constant. If a question should come in this format, what is the formula, which is this? Then the next question that you may likely see is that what is the value of R? Then what is the R there? The R is a constant, and the constant is what? The universal gas what? Constant. Now, the next question here is, which is very, very simple and very, very difficult. If you are a JAMB student that is also watching this video, please, I want to take note of this question. According to Graham's law, lighter gas diffuses. Is it faster? Is it slower? How do they diffuse, please? Lighter gas diffuses faster than heavier gases. So if the gas is lighter, the lighter you are, the higher the rate of your diffusion, the faster the rate of your diffusion. The heavier you are, the higher the, if you have forgotten this in exam, just ask yourself, if you someone that is fat and someone that is, sorry for using the word fat, but someone that is fat and someone that is slim, they said something just happened in a place, who will run faster? The answer is what? The person that is slim, right? So the gas that is lighter diffuses faster compared to the one that are what? That are heavier. Let me give you an example. H2, yes. N2, yes. CO2. Which of the following gas, let me add oxygen to it. Which of the following gas will diffuse faster? Let me show you something. Hydrogen, what's the atomic number of hydrogen? Atomic mass, 1. 1 times 2, here will give us what? 2. Nitrogen is 14. 14 times 2 will give us what? 24. Carbon is 12. Oxygen is 16. 16 times this will give us what? 32. 12 times 32 will give us what? 44. While oxygen is 16. 16 times 2 will give us what? 32. So the one, which of them is the lowest here? Hydrogen, followed by what? Nitrogen, followed by what? Oxygen, followed by what? CO2. So the lighter the gas, how do you know the gas that is lighter? It's not for you to look at it, this one is the heaviest. No, it doesn't work like that. You have to know the atomic number, the atomic mass, then you calculate to give you your what? Your answer. As simple as that. Let me give you something. Sodium is 23. Here is 11. Here is 23. And let's say oxygen here is 16. Sorry. Let me give you another element. Argon here is 18. Here is 40. Which of them will diffuse faster? Is it sodium or argon? Your mind will always tell you that the answer is what? Sodium, because sodium is 23 and here is what? Is 40. Sodium is a solid. This one is a what? Is a gas. So gas diffuses faster than what? Than solid does not even diffuse. Solid does not diffuse. So if you see a question, first of all, ask yourself which of them are gases. Like all of them here, they are gases. That's why you have to use it. But if you see two elements, ask yourself which of them is gas. So the gas will always diffuse faster compared to the other one. That is the end of the story on properties of what? Of gases. Let's quickly move to the historical development and structure of atom. Please, if you have any question, kindly drop it. I'm going to answer it right here and now. Yes, let me go through this if I have any question. No, sodium is not 28. Sodium is 23. Please take note. Sodium is not 28. Sodium is 23. Yes, ask your question. 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 Now, okay, I'm too fast. Sorry, I will be slow. I don't usually teach very slow, but I will try to be very slow. Now, the next concept we'll be dealing with here is historical development and structure of atom. Okay, now look up. The first one I have here, the scientist who proposed the atomic theory in 1808. In 1808, the atomic theory, what's the name of the scientist? The name is what? John Dalton. That's the name. So it was John Dalton who proposed the atomic theory. On that very good question again, let me quickly write isotope, isobar, isotones, isodiaphers, which is that one again? Isodiaphers, okay, isomer, allotrope, then isoelectronic species. Then the last one is Isosteres. Now, these are some questions you may likely see in your exam. Let me quickly go through this so that for clear understanding. Now, if you see a question like this in your exam, which of the following is isotope, which of the following is this, which of the following is that? Now, isotope, they have the same proton number or atomic number. So if you have hydrogen 1, under hydrogen again 2, under hydrogen again 3. Now, if you notice, the proton number here is the same. This is proton, this is deuterium, and this is tritium. So if you have anything that has the same atomic number but different mass number, it is called what? Isotope. For example, we have chlorine, which is 35, and we have another chlorine, which is 37. So here is 17, here is 17. They have the same atomic number, proton number, but different what? Different mass number. So they are called isotope. Now, if you look at argon, argon is 40, here is 18, and calcium is 40, here is 20. If you look at it, they have the same, they have different atomic number, different proton number, but they have the same mass number. So if you have the same mass number, you are called what? Isobars. Then the next one we have there is the same neutron number. For example, let's say boron, hydrogen, helium, boron is 5, here is 10. Then which other element will I bring again? Let's say there's another element S, here is 6, here is 11. Let's assume carbon. Let's assume it's carbon. Carbon is 6. Now, 5 minus this, 10 minus 5 will give us what? 5. 6 minus 11. Sorry, 11 minus 6 will also give us what? 5. So they have the same neutron number. Remember, neutron number is equals to mass number minus what? Atomic number. So if they have the same neutron number, they are called what? Isodiaphers. Sorry, they are called isotopes. Now, isotones, yes. Now let me show you this. Here is 10, here is 22, and here is 40. Let me reduce the value. Here is 12, here is 26. Now, if you look at this, first of all, what is the proton number? Proton number is 10. What is the proton number here? Proton number here is what? Is 12. What is the mass number? Mass number here is what? Mass number here is 22. What is the mass number? Mass number here is what? Is 26. What is the neutron number? 22 minus 10 will give us 12. This minus this will give us what? 14. So you realize that nothing is the same here, right? So how do you now get isodiaphers? Isodiapher is talking about same difference, same neutron to proton difference. So now let me check. Neutron minus proton, 12 minus this. Listen, no, 12 minus this will give us what? 2. 14 minus this will give us what? 2. As long as the difference is the same, they are called what? Isodiaphers. How do you know? Instead of you to even solve this whole rubbish in your exam, like what I do say, this is the Gido approach to chemistry. I'm not teaching you to understand most of all this stuff. I just want you to know the easiest way to pass your exam. Now, if you have something like this in your exam, first of all, this times 2. This times 2 will give us what? 20. 20 plus 2 will give us what? 22. This times 2 will give us what? 24. 24 plus 2 will give us what? 26. If you have on that one again, let's say here is 13. 30 times 2, that will give us 36. Sorry, 26. 26 plus 2 will give us what? 28. All of them are isodiaphers. So if you multiply this value by 2 and you add it to something to it, give us, look at this one now. 5 times 2, 10. Is not, you didn't add anything to it. 6 times 2 will give us 12, but this one will give us 11, so it can never be the same. So the question should be, for example, let's say 5 times 2 is 10. 10 plus 4 will give us what? 14. 6 times 2 is 12. 12 will now be plus 4. 12 plus 4 will give us what? 16. So in this case, they are what? Isodiaphers. So once you multiply the proton by 2 and you add any value to it to give you this, follow that same pattern. If it will give you this, the next look like, if it should, then you are correct. Then for isomers, we are talking about the same molecular formula but different structural formula. But most cases, they always call it the same binding energy. So they have the same molecular formula but different what? Structural formula. Then what are allotropes? Allotropes, they exist in 2 or more various, these are chemical elements or substances that exist in 2 or more various forms in the same physical state. They exist in 2 or more various forms in the same physical state. For example, let's say water can exist in 3 forms, solid, liquid, and gas. These are 3 different states. But allotrope, it can exist in 2 or more various forms in the same physical state. Like solid water can be this, can be that. An example of that, we have the carbon. Carbon has 2 allotropic forms, which is graphite and what? And diamond. There are other ones, we have the those ones, they are under the allotrope. Sorry, they are under the amorphous carbon, which is the shapeless carbon. Then isoelectronic species. If they have the same electronic configuration, they are isoelectronic species. Or if they have the same electron, allotrope exists in 2 or more various forms, but the same physical states. Now, isoelectronic, they have the same electron. For example, sodium is 11, magnesium is 12, oxygen is 8, neon is 10. Now, sodium plus is what? It gave us 1 electron. 2 plus gave us 1 electron. 2 minus gave us 1 electron. So if sodium should give us 1 electron, sodium will become what? 10. Magnesium is 12, give out 2 electrons, will become what? 10. Oxygen is 8, accepted 2 electrons, become what? 10. Neon is 10, is stable. So in this case, they have the same electron. And if you are going to write the electronic configuration of all of them, will be 1s2, 2s2, and 2p what? 6. So they have the same electron number. Because of that, they are called isoelectronic what? Species. Now, let me give you the last one. If you have something like CO2 and then N2O, this under examination question you will see CO2 and N2O. First of all, how many atoms do you have here? 3. How many atoms do you have here? 3. That's the first step. Then carbon has how many electrons in the atmosphere? 4. Oxygen has how many electrons? 2. So here is 4. The other one is what? 2. How many oxygen do you have here? Oxygen has how many electrons in the atmosphere? Sorry, is 6. Because you have 2, 6. That's oxygen. So here is 6. The how many oxygen do you have here is 6. Is 2 rather. Carbon has 4. Carbon is 2, 4. Oxygen is 2, what? 6. Nitrogen is 2, 7. Okay, now we are good to go. So that means we say 4 plus 6 plus 6. 4 plus 6 plus 6, that will give us what? That should give us 16. Then nitrogen is 7. So we have 7 hydrogen helium. Sorry, nitrogen should be 5. Because nitrogen atomic number is 7. Hydrogen helium, lithium, barium, boron, carbon, nitrogen, which is 5. So the answer will be 5. How many nitrogen do you have there? Plus 5 plus oxygen is what? Oxygen is 6. So 5 plus 5 is 10. 10 plus 6 is what? Is 16. So once they have the same isostates, they have the same atoms and the same what? Electron. Now let me give you another example, maybe for clarity. Let me check. Okay. NO2 minus and O3. Oxygen, nitrogen is 2, 5. Oxygen is 2, 6. Now, if nitrogen is 2, 5, we have 5, which is the outermost electron, valence electron. Oxygen is what? 6 plus 6. Minus means you have given out 1 electron. So if you have given out 1 electron, become minus 1. So here will give us 12. 12 plus 5. That will give us let me subtract this from it, which is 11 in total. Plus 12, 13, 14, 15, 16. Sorry. I want to be very sure. 17. And if you subtract 1 from it, here will become what? 16. So we have 16 here. So 16 electron for NO2 minus. Then oxygen. Oxygen will be, how many electrons do you have in the atmosphere? 6. So you have 6 plus 6 plus 6. Let me confirm something again. 12, 13, 14, 15, 16. Sorry, I made a mistake. Here is minus. As long as it is minus, you are not giving out electron, you are accepting electron. So it becomes plus 1. So if you add 1 to it, minus means you are accepting, plus means you are giving out. The sequence of the correction. So it will be 6 plus 6, that's 12. 12 plus 6, that will give us 18. So here will give us what? 18. Then oxygen, we have 3 oxygen here, which is 6 times 3, or 6 plus 6 plus 6. That will give us what? 18. So as long as you have 18 and 18, they are called what? Isosteres. Let me give you another common example that you also see in your exam. We have CO and nitrogen gas. Now, if you look at CO and nitrogen gas, carbon is 2, 4, oxygen is 2, 6, nitrogen is 2, 5. So carbon plus oxygen, which is 4 plus 6. 4 plus 6 will give us what? 10. Then nitrogen, how many nitrogen do you have here? Is 2, which is 5 plus 5 will give us what? 10. How many atoms do you have here? 2 atoms. How many atoms do you have here? Is 2 atoms. So in a case like this, they are called what? Isosteres. So isosteres, they have the same atom and the same electron. Same electronic configuration is electron. Isoelectronic species. Same physical state is allotrope. Same binding energy or the same molecular formula but different structural formula is isomer. Isodiapha is talking about same neutron to proton difference. Isotope is talking about neutron. Isobar is talking about mass number. Isotope is talking about what? It's talking about proton number. So please, let's take note of that. Then the next question I have here. Okay, Faraday's work of electrolysis provided evidence for the existence of dash. Faraday's law of electrolysis provided evidence Ah, good. I'll try to be slow. I'll try to be slow. Now, okay. Now, Faraday's law of electrolysis provided evidence for that. Ah, God. This body is turning to black now. Now, Faraday's law of electrolysis provided evidence for the existence of what? Of electron. So please take note. According to Faraday, works of electrolysis talking about what? Electron. Take note of that. Then the next thing I want you to take note of, E is for J.J. Thomson. P is for Ernest, NSR. N is for James C. Y. N is for Ernest Rutherford. Now, let me explain what I mean by this. In your exam, a question might come in this format. Who discovered electron? Please, for DELSU, or if you are writing JAMB, the answer you have to pick is what? Electron, J.J. Thomson. So it was J.J. Thomson. He was one that discovered what? Electron. And who discovered proton? Proton, the person that discovered proton is the same person that discovered nucleus. Please, electron is negatively charged. This is the structure of an atom. This one is positive. This one is neutral. So here is what? Is proton. Here is neutron. And we have electron, which is negative. Electron. These two, they are found in the what? In the nucleus. And all of them, they are found in the where? In the atom. So what I want you to take note of is that electron is negatively charged, proton is positively charged, while neutron is what? Is neutral. But the nucleus is positively charged. So in your examination, if they ask you what is the charge of the nucleus, the answer is what? Is positive. It is not neutral. The neutron is the one that is neutral. And the person that discovered the nucleus that is positive also discovered the what? The proton as the what? As a positive, which is Ernest Rutherford. Ernest Rutherford. Then the person that contributed to it is Eugene Gostin. So if you see this name, he is not the one that discovered proton. No, he only contributed to the discovery of the proton. So, but if Ernest Rutherford is not in the option, which I know will be in the option, then you have to pick what? Gostin. Then who discovered the one that is neutral, which is a neutron? The answer is what? James Chadwick. James Chadwick, neutron. J.J. Thomson, J.J. Thomson, electron. Then the guy that used the alpha scattering experiment is called what? Ernest Rutherford. And it was the one that discovered the proton and the neutron, which the proton and the nucleus, not the neutron. Neutron is James Chadwick. Proton and the nucleus. Nucleus, Nucleus. And proton was discovered by one man called Ernest what? Rutherford. The next question here. The charge of an electron was determined by R.A. Millikan using oil drop experiment. According to R.A. Millikan, the experiment he did was what? Was the oil drop what? Experiment. So it was R.A. Millikan that conducted the oil drop experiment to detect the charge of what? Of electron. So take note of that. Then the next question here, okay, I've explained neutron. So that is the end for historical development of what? Of atom. Let's move to the next concept, which is the periodic table. The periodic table. Let me check if there is any comment here. I'm not teaching this again live, and I'm not teaching this again live. So please, if you have anyone that is not in this video now, please reach out to him, tell him to go and join, tell him to come and join this video immediately. I'm not teaching again live. Please, let's take note of that. And make sure you are with your book, make sure you are writing, make sure you are writing, make sure you are writing. Please, make sure you are writing. It is very, very important. Make sure you are writing. So let's continue. Let's continue. Please, if you have any question, feel free to drop that in the comment section. I will attend to it immediately. So, the first question under the periodic table was discovered in 1869 So it was constructed in 1869 by a man called Dmitry Ivanovich Mendeleev. Dmitry Ivanovich Mendeleev was the first that constructed the periodic table. He was not actually the first person. In second semester, you will know that there are other people that actually contributed to the periodic table before this guy. But the periodic table we are even using now is not considered by this. It's a remote, but let's leave that aside. So let's focus on your exam, which is section 101. The periodic table that we are using was constructed by what? Dmitry Ivanovich Mendeleev. But in your section 111, you will discover that is not, that answer is not even correct. But let's work with that answer for the meantime. Then the next question here says, in the model periodic table, horizontal rows are known as, please, the periodic table is arranged, these are horizontal, and this is what? Vertical. So we have the vertical arrangement, now we have horizontal arrangement. The vertical is known, the horizontal is known as period, while the vertical is known as what? As group. The horizontal is known as a row, while the vertical is known as what? As column. Please, if you are asked in your exam, the arrangement of elements in horizontal is called period. The arrangement of elements in row is called what? Period. The vertical arrangement of elements is called what? Group. The arrangement of elements in column is called what? Group. So that's something you should know. That's something you should know. And elements that are in the same period, they belong to the same energy level. Energy level. If you are in the same period, that means you have element in period 1 they belong to the first energy level, element in period 2 second energy level, period 3 third energy level, period 4 fourth energy level. Now, elements in the same group, they have the same valence electron. They have the same valence electron. And because they have the same, that's why sodium can give us 1 electron, potassium can give us 1 electron, francium can give us 1 electron. Which is that element again? Lithium can give us 1 electron, calcium can give us 2 electrons, magnesium can give us 2 electrons. So any elements like group 1, they give us 1 electron. Group 2, they give us 2 electrons. So they have the same, let me add, physiochemical property. If not the same, but they have similar physiochemical what? Properties. So that's the same energy level. They are in the same horizontal, they are in horizontal arrangement, they are in the same row, and they is called what? Period. While for group is vertical, is column, and they have the same what? Valence electron. And because of that, they have the same physiochemical what? Properties. So please take note of that. Electropositivity refers to the ability of an atom to dash. Electropositivity refers to the ability of an atom to give out electron. So the ability of an atom to lose electron is called electropositivity. And an element that has the ability to give out electron is called electropositive element. And electropositive element, the other word for them is called what? Cation. So you see that you are electropositive element, or you can be called what? Cation. So please, let's take note. The board is too bright. Okay. I've seen what this person is saying. I can't really work. I can't. Hey God. I will try to. I understand what you are saying. I understand what you are saying now. Ah God. Excuse. I believe it's better now. I believe it's better now. Please, if it's better in Korea, let me see. Let me know. Is it better now or is it worse?
It is worse.
I feel like it's better now. Ah God. So that means you can. Yeah, it's better now. It's better now. You can. Okay, is. But no, I understand. But I feel like let's continue with the class, because if you keep on adjusting this board, you might know. We might. Ah God, oh, is really bad. Is really bad. Okay. Let me check something else. Please. There are a lot of things to yes. Okay. I don't really know what to do. Ah, God, though. I feel like it's worse so because what I'm seeing here. If we continue like this, we are not going to learn anything. No. That's just the truth. If you continue like this, we might not really learn anything. So let me stay here. I believe that we can. Oh God. And once I leave this thing. Okay, let me just continue because of time. Because if we continue like this, we might not do anything. Okay, now electropositive element, they has the ability to give out electron. Please, let's take notes. I will try to avoid this part of the board. I will try to avoid it. So electropositive elements, they have the ability to do what? To give out electron. So as long as they have the ability to give out electron, they are called electropositive or what? Or cation. Why the whole process is called what? Electropositivity. Why the ability to accept electron is called what? Electronegativity. Why the element itself, they are called what? Electronegative element. Another good question is that transition elements are located between what? Please, they are located between group 2 and what? Group 3 in the periodic table. If you look at your periodic table, this is how your periodic table look like. Then you have something like this. This is how your periodic table look like. Now, these are the D block element, and it is between the S block and the what? P block. In your examination, is that it is between the S block or the P block? It is because of this other lightning, not this one. Yeah. So is that because of the S block? Is it between the S block and the P block, or between group 1 and what? Sorry, group 2 and what? And group 3 in the periodic table. So that's something I want you to take note of. Then the next question here we are going to explain. Oh, I leave it. This one. No, I leave it first. Leave it. It's clear like this. Did it increase again? Don't worry, let's manage it. Let's manage it. Now, the next concept we are going to explain here is lanthanide. Now, lanthanide are found at the bottom of the periodic table. Lanthanide, and what? And actinide. Now, a question might come, actinide, yeah. Now, lanthanide are found at where? Period F. Transition elements are found where? D block. Now, the lanthanide are called the rare earth elements. The rare earth what? Elements. Why the actinide are called the what? The transition element. So transition element is for actinide. Sorry, inner transition. Both of them are even called the inner transition. Both of them are called the inner, but these are rare earth elements. But this inner transition, which is the actinide, they are mostly called what? The artificial element. The artificial element, because they are majorly produced from what? From what's it called again? They are majorly produced from radioactivity. So during radioactive process, that's when you get those elements. Then the next concept I will quickly rush into is electronic configuration. Electronic configuration. Now, electronic configuration is actually done in two ways, but generally, electronic configuration is the arrangement of elements of electrons in their octet or in their shape. Now, listen to this question. The electronic configuration refers to the arrangement of electrons around the nucleus based on their dash: A, mass; B, energy level; C, charge; D, size. Please, the arrangement of electrons is usually based on their what? On their energy level. The arrangement of electrons is usually based on their what? On their energy level, not on their size, not on this, not on that. It's usually based on their what? On their energy level. Please take note of that. Then another one again I want you to take note of is the N plus L rule. The N plus L rule. Now, N is the principal quantum number, while L is the azimuthal quantum number. Now, the principal quantum number can be 1, can be 2, can be 3, can be 4, can be whatever. Let me leave it like that. But the azimuthal quantum number can be S, can be P, can be D, can be what? Can be F. If this S is 0, P 1, D 2, and F is what? Is 3. Now, please, I want you to save this to memory before we continue with the class. N can be 1, can be 2, but S orbital is 0, P is 1, D is 2, and F is what? Is 3. The worst question that you see in your exam is 3D and 4S. Which of them is more stable? The higher the energy level, the lower the stability. I repeat, the higher the energy level, the lower the what? The stability. So 3 plus D. What is the value of D? D is 2, which is what? Equals 5. Then 4. 4 plus what's the value of S? S is what? Is 0. Is equals to what? 4. So which of them has a higher energy level? 3D is higher. But which of them is more stable? 4S. 4S is what? More stable. While 3D is what? Is higher energy level. Because the higher the energy level, the lower the what? But originally, if you see 3D and 4S, we think that 4S is higher than 3D. But based on the N plus L rule, 3D is higher than what? Than 4S. So take note of that. Let me give you another example again. 4F and 6S. Which of them is higher? Now let's check. 4 plus F. F is what? Is 3, which is equal to what? 7. Why 6? 6 is 6 plus S 0, which is equal to what? 6. So that means 4S is higher than 4F is higher than what? Than 6S. Then another thing, if you want to arrange it, let's say if you want to arrange all of this 6 now, would that be 4S is less than 3D is less than 6S is less than what? Than 4F. So this is based on their what's it called? Their energy level. But if it is based on stability, 4S is greater than 3D, greater than 6S, greater than what? 4F. This is based on their what? Their stability. Because I just made us to understand that the higher the energy level, the lower the stability. And the lower the stability, or the higher the stability, the lower the what? The energy level. On that question again, the maximum electron that can accommodate in the M share, please, we have the K share, we have the L, we have the M, and we have the N. Here is 1, here is 2, here is 3, and here is what? 4. The value of N, the value of small letter N, which is the value, the principal quantum number for K is 1, the principal quantum number for L is 2, the principal quantum number for M is 3, the principal quantum number for N is what? Is 4. Now let me show you this. The formula we use to calculate the number of electrons is 2n squared. So 2 times K, which is 1 square, will give us what? 2 times 1, which is equal to what? 2. Then let's solve for L. 2 times L square, which is what? 2 square. That will give us 2 times what? 4, which is equal to what? 8. M will give us 2 times what? 3 square, which is equal to 2 times 9. 3 square will give us 9, which is equal to what? 18. Here is what? 18. Then N will give us 2 times 4 square, and 4 square is 16. 2 times 16 will give us what? 32. And here is what? 32. So that's why I always say 2, 8, 18, 32. But once we advance, I will tell you the formula is actually 2, 8, 8, 18, 18, 32, what? 32. But in your exam, K is 2, L is 8, M is 18, N is 32, Y, O is what? O should be 50. So if we have O is 5, which is, we have 2n square, which is 2 times 5 square. 2 times 5 will give us what? 25. 2 times 25 will give us what? 50. So no matter how they treat the examination question, This should be your answer. But they should ask you, what is the value of n? What is the value of the principal quantum number for n is 3? How many, like, look at this question now. The maximum number of electron, not the value of the principal quantum number in K. The maximum number of electron, this is maximum electron, which is maximum number of electron. So they ask you, the principal quantum number for K is 1, for L is 2, for M is 3, for N is 4. But the maximum electron for K is 2, L 8, M 18, N is what? Is 32. In case you forget this in your exam, just use this formula to solve and you get your answer as soon as possible. Then another thing again I want to take note of, the principal quantum number mainly describes dash of the electron. Mainly describe dash of the electron. We have option A, this, that. Let me explain real quick. We have the principal quantum number, we have the azimuthal, we have the magnetic, and we have the what? The spin. Now, the principal quantum number talks about the energy level. The azimuthal quantum number talks about the sub-energy level, which is also known as what? As orbital. Either sub-energy level or what? Sub-energy level or orbital. While the magnetic quantum number, magnetic, talks about the suborbital or the sub, this is already sub-energy level. You can call it sub-energy level or suborbital. So the suborbital can be P, which is yes, the degenerate orbital, which is degeneracy. Let me use that. Degeneracy. Because the P orbital has how many? 3. D orbital has how many? 5. F orbital has how many? 7. And S has how many? 1. So please take note of that. So what about the spin? If you draw any box like this, one of the spin is going up, the other one is what? Is coming down. So it shows the direction of the electron. So your exam, the principal quantum number talks about the energy level. Azimuthal talks about the orbital or sub-energy level. Magnetic talks about the suborbital, while the spin talks about what? The direction of what? Of electron. The next question here says, the electronic configuration of sodium is dash. Of sodium is very easy. 1s2, 2s2, 2p6, 3s what? 1. Assuming it is sodium ion, that means sodium is 11. Sodium ion will be what? 10, because it has given out 1 electron. So because of that, this 1 electron will have to what? To disappear. So this one is for sodium ion. Then the next question I have here, zinc, cadmium, and mercury, they are not transition elements. I repeat, zinc, cadmium, and mercury, they are not transition elements. The question is why? Option A, they have completely filled d orbital. Please, the reason why they are not transition elements is because their d orbital is completely filled. For you to be a transition element, I repeat, for you to be a transition element, your d orbital will be partially filled, not completely filled. For you to be a transition element, the d orbital will be partially filled, not completely what? Filled. So we can have d1, we can have d2, we can have d3, we can have d4, we can have d5, we can have d6, we can have d7, we can have d8, we can have d9. So if it is d10, that means it is not a what? A transition element. Why is not a transition element? Because it is fully what? Filled. The next question, 1s, 2s, and 3s are dash. 1s, 2s, and 3s. Let me read the question. 1s, 2s, and 3s differ in dash. Differ in dash. Option A, block. B, orbital. C, electronic configuration. D, energy level. Please, they differ in their energy level. They belong to the same group. They belong to the same orbital, but this belongs to the first energy level, second energy level, and third energy. If you see any question like this, they belong to different energy level. And if you have 5p, belong to which energy level? 5 energy level. If you have 6s, belong to which energy level? 6 energy level. If you have 7p, belong to which? 7 energy level. So the n, and what is the value of the principal quantum number for 7p? The answer is what? Is 7. If there's something like this, so what is the value of the principal quantum number? 1, 2, 3. As simple as that. So the number that you see is actually the principal quantum number. So take note of that. Then Substances with unpaired electron are dash. The answer is paramagnetic. If they are paired, fully paired, for example, if you have 3p, for example, if you have 3p6, it means 3p has 3 orbitals. Remember, 3, 1, 2, 3. Let me show you something first. If it is 1, it is unpaired. If it is 2, it is unpaired. If it is 3, it is unpaired. If it is 4, it is unpaired because we have 2 unpaired. If it is 5, it is unpaired. If it is 6, it is what? Is paired. And if it is paired, it is diamagnetic. But if it is unpaired, it is what? Paramagnetic. So let's go again. If it is 1, is it para or di? It is para. How many unpaired electrons do you have there? Is 1. If it is 2, 2 unpaired electron. If it is 3, 3 unpaired electron. If it is 4, it is 2 unpaired electron because this one is paired and these two, they are what? Unpaired. If it is like this, we have 1 unpaired and 2 paired. If it is like this, it is what? Paired. If it is like this, even though you have 2 pairs, it is also called what? Paramagnetic, because there is a presence of what? Of unpaired electron. So once all of them is paired, that is when it becomes what? Once all of them is paired, that's when it becomes what? Diamagnetic. Okay. Ah, God, I wish we have enough time. Let me check the time. Jesus. Okay, I should avoid the middle part of the board. I will try. I will try. I will try to avoid. Now, look up. Look up. The next question I have here, the half-bar principle, please. We have half-bar, we have poly, and we have Hunt. Now, the half-bar principle talks about you should fill this lower one first before you move to the what? The higher one. First of all, fill the smaller children before you fill the higher children. Then poly is talking about 2 electrons. 2 electrons. Then Hunt is talking about what? Singling before you what? You paired. That means talking about degenerate orbital. You have to fill them. If you have 5 phones, you have to, if you buy 5 phones for your, if you bought just let's say 1 phone and you have triplets, you have to give to 1. If you bought 2, you can't give 2 to 1. You give 1, then you give 1 the other. If you have 3 triplets and you bought 3 phones, it is wrong for you to give 2 to 1. You give 1. If you have 4 phones for your triplet, you give them 1 first, then the last one, anybody can take it. So that's how it works. So that's what Onsu actually explains. On that very good question again, the orbital angular momentum quantum number, the orbital angular momentum quantum number is also known as what? Let me go again. The orbital angular momentum quantum number, orbital angular momentum quantum number is also known as, that was not actually the question. The orbital angular quantum number, L, describes dash. Please, the answer is the shape of the orbital. But one thing I want you to know, the orbital angular momentum quantum number is also known as the azimuthal quantum number, which talks about the shape, which is, I said, orbital. So when I talk about orbital, I'm talking about the shape of the orbital generally. So that's what the orbital as angular momentum quantum number explains. But there's something I want you to take note of here. Principal quantum number is denoted by the symbol N. Azimuthal is denoted by the symbol L. Magnetic is denoted by the symbol MS. ML. While spin is denoted by the symbol what? MS or just S. So any of them is the correct one. So please, if you see this in your exam, principal M, angular M, magnetic quantum number ML, while spin is MS or what? Or S. So take note of that. Under useless question again. For P subshare, the value of L is dash. For P subshare, what is the value of L? I told you the other time. S is 0, P is 1, D is 2, and F is what? Is 3. So what is the value there? The answer is what? Is 1. As simple as that. That's why we are here for. the Gido approach to what? To chemistry. We are going to simplify chemistry. We don't need to do all of those things. Now, the next concept we are going to play with here is hybridization. Now, the first question I have here, hybridization is the missing of atomic orbitals of dash. Hybridization is the missing of atomic orbitals of dash. A, different energy. B, similar energy. C, unequal energy. D, different atom. Please, the correct answer is similar energy. So hybridization always deal with similar energy. That is what hybridization explains. So hybridization always explains what? Similar energy. They must have similar energy. Then, another thing you should take note of is that the orbital form from hybridization process is called hybrid orbital. This is where I'm going to stay. I'm going to explain some key terms here, please. I want you to follow me closely. I want you to follow me very, very close. Now, look up, class. The process of blending two atomic orbitals to form new hybrid orbital is called hybridization. What is formed is called what? Hybrid orbital. Why the process itself is called what? Hybridization. We can form different kind of orbital. We can form sp. We can form sp2. We can form sp3. We can form sp3d. We can form sp3 what? d2. We can even form d2sp. So we can form, there are different kind of hybridization that can be formed, but for our 100 level, these are the major ones that we see. Now, follow me closely. sp hybridization has how many equivalent orbital? sp has 2 equivalent, sp2 has 3 equivalent. Yeah, 3 plus 1, because 2, how many s do you have? 1. How many p do you have? 1. So 1 plus 1 will give us 2. 2 plus 1, 3. 3 plus 1, 4. 3 plus 1 plus 1, 5. 3 plus 2, 5 plus 1, 6. So here has 2 equivalent orbital. Here has 3. Here has 4. Here has 5. And here has what? 6 equivalent what? Orbital. So those are some of the things I want you to take note of. And aside that, the next question here says, now let me show you something real quick. sp, I'll focus on these 3. sp is linear. sp2 is trigonal, while sp3 is what? Tetrahedral. Except trigonal planar. This is trigonal pi parameter. So, but I'm going to explain all of that. Now, in your exam, the bond angle for linear is 180 degrees. Yes, here is 120 degrees, while here is 109.5 what? Degree. So if you have anything like this in your exam, please know what to work on. Then another thing again I also want to explain in this hybridization, in your examination, there is that which is called the steric number. And the steric number is sigma bond plus number of lone pair electron. Now, if you have something like CH4, right? So carbon is C, focus on carbon. Carbon is 2, what? 4. So if carbon is 2, 4, then that means carbon will have 4 electrons at the atmosphere. It can draw 4 structures. So hydrogen, 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 hydrogen. Now, how many sigma bonds do you have? 1, 2, 3, 4. So the answer is 4 plus how many lone pair electrons do you have? There's no lone pair there. So the answer is what? Is 0. 4 plus 0 will give us what? 4. And if your answer is 4, what do you have? sp3. Let me give you another example. Let's say nitrogen. Nitrogen has how many on pair electron? Nitrogen has 5. 1, 2, 3, 4, 5, right? Nitrogen has 5. Now, if you have NH3, that means hydrogen will be here, hydrogen will be here, hydrogen will be here, and there is lone pair electron here. So how many, the steric number will be equal to how many sigma bonds do you have? 1, 2, 3. So we have 3 sigma, and how many lone pair electron do you have? Is 1. So 3 plus 1 will give us what? 4. And 4 is what? sp what? 3. As simple as that. Now let me give you another one again. H2O. Which of them is the center atom? Is oxygen. I mean, which of them has a lower number? Is oxygen. So oxygen has how many electrons? Oxygen is 2, 6. So that will be 1, 2, 3, 4, 5, 6. So this one of the electron will go for hydrogen. This under one electron again will go for hydrogen. That's H2O. Now, in this case, the steric number will be hydrogen. How many sigma bond do you have there? Is 2. How many lone pair? This is 1 lone pair. This is 2 lone pair. Is 2. So that will be because of 4. That's sp what? 3. As simple as that. Let me give you something that is kind of a bit complex. PCl5, phosphorus. Phosphorus is, let me give you this: hydrogen, helium, lithium, beryllium, boron, sodium, magnesium, aluminium, silicon, phosphorus. So phosphorus 1, 2, 3, 4, 5. Phosphorus can have 5 electrons in the atmosphere. So phosphorus 1, 2, 3, 4, 5. How many electrons do you have? How many chlorine do you have there? 5. 1, 2, 3, 4, 5. So the steric number will be equal to, how many sigma bond is 5? How many lone pair is 0? 5 plus 0 will give us what? 5. And 5 will give us sp3 what? D. Then the next one I also want to explain is BeF2, beryllium. Now, beryllium, hydrogen, helium, lithium, beryllium. Beryllium has 2 electrons. So we have Be1, 2. How many fluorine do you have? 2. Fluorine will take one of these electrons. Fluorine will take one of these electrons. So generally, any lone pair then we have 1 sigma, 1 sigma. So our steric number is equals to 2 plus what? Plus 0. And 2 plus 0 will give us 2. So if your answer is 2, what is the answer? SP. So that's how you usually do all of these things. So it becomes very, very easy if you really want to solve any of these questions in your exam. If they should come out to your exam, I don't even want you to solve. Operation look and click. You already know that PCl5 will be PCl5. The answer will be 5, which is sp3d. You already know that which is that one again? Water is there is 4, which is the sp3. You already know that which is that one again? Beryllium fluoride is 2, which is sp. You already know that methane is 4, sp3. You already know that ammonia is what? Is 4, which is sp3. Ammonium, which is, if you don't have N, hydrogen, 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 and here is hydrogen 2, is still 4, which is also going to give us what? sp3. Let me clean the board. So the next concept we are going to play with, is chemical kinetics. Next concept we are going to play with is chemical what? Kinetics. Let me check if we still have a lot of questions here. Please, let's share the video to other people so that there are a lot of things to learn from this video. There are a lot of things to learn from these videos. So please, let's share the video to others so that they can actually learn a lot of things from it. Now, the next concept is chemical kinetics. Chemical kinetics, chemical kinetics is a branch of chemistry that deals with the study of dash. The answer is rate of conversion of reactant to what? To product. The rate at which reactants are being converted to product, the branch of chemistry that studies that is called what? Chemical what? Kinetics. As simple as that. Then number two, the rate of a reaction increases with time. The rate of a reaction increases when the time dash. Now, if the rate of the reaction increases, what happens to the time? The time becomes short. If you increase the rate, the time becomes short. Or if you decrease the rate, the time becomes what? Long. That's actually the shortest answer to that question. Then, this is where our problem comes from. Now, they said rate is equals K. Here is A raised to power M. Here is B raised to power N. Now, the overall order of this reaction is dash. The overall order of this reaction, if it's something like this in your exam, The answer is just for you to pick n plus what? N is the sum of the powers. So once you sum the powers together, you are going to get what? The weight. As easy as that. Then the next concept I would love to touch. In the reaction, hydrogen plus iodine to give us 2Hi. What is the molecularity of this reaction? Is it unimolecular? Is it bimolecular? Or it is star molecular? Now, how many number of moles do you have here? 1. How many number of moles do you have here? 1. Which is 1 plus 1 will give us what? 2. 2 is bimolecular. 1 is not mono. 1 is unimolecular. 2 is bimolecular. 3 is star what? Molecular. So please take note. Someone will ask me, what about 4? We can only have 3. So take note of that. Now, for the rate law, if the sum of the power is 1, it is first order. And the molecularity of a chemical reaction can be determined theoretically, which is, if you look at what you have there, 1, 1, you can determine that. But for rate law, cannot be determined theoretically. You have to conduct an experiment. So rate law is determined experimentally, while molecularity of a chemical reaction is determined what? Theoretically. Take note of that. That's another examination question. No? So please take note of that. Now, one thing I want you to take note of in all of these things is that if the sum of the powers is 1, it is unimolecular. If the sum of the powers is 2, if the sum of the powers, which is rate law, is 1, it is first order. If the sum of the powers is 2, it is second order. If the sum of the powers is 3, it is third order. If the sum of the power, okay, the person that said you don't understand a steric number, I have a videos on that separately, so you can actually go through that after this one. So if the sum of the power is 3, it is third order. So there are other order of reaction, which is pseudo order, the zeroth order, but I'm not going to explain of that in this class. So the only one I'm going to focus on is the first order and what? First order, second order, and third order. Now let me show you something. If you have rate is equals to K N2 and H3, H2 here is 2. Now if you look at this, what is the number of mole here is what is the power here is 1, what is the power here is 2. So 1 plus 2 give us what? 3. So it is third order. So assuming you have K, which is this is the constant, and let's say here is N2 and here is H2. Now in this case, is it first order or second order? The answer is what? Is 1 plus 1 give us 2. So 2 is what? Second what? Order. Now assuming you have something like K, here is H2O, close the bracket. Now in this case, is it first order or second order? You are seeing 2 inside. You don't need to bother about the 2. Focus on the power. Is anything here? No. Which is what? 1. So this one is what? Is first order. If the sum of the power is 1, it's first order. If the sum of the power is 2, it's second order. If the sum of the power is 3, it is what? Third order. I'm very tired, but let's continue. Now, the next concept we are going to play with is chemical combination. Chemical combination. Chemical combination. Now, according to which scientists, during any physical and chemical change, the total mass of the reactant must be equal to the total mass of the product. The answer is what? Lavoisier. According to Lavoisier, for a chemical reaction to be balanced or whatever, the number of mole of the reactant must be equal to the number of mole of what? Of the product. So Lavoisier was the one that made that statement. Number 2, Redox reaction involves dash. Redox reaction involves dash. Option A, or only oxidation. Option B, reduction. Option C, transfer of electron. Option D, breaking and formation of bond. Please, the answer is transfer of electron. But please take note, redox, look at the name, red. Thus, reduction, oxidation. So that means there is loss of electron, and there is gaining of what? Of electron. Gain of electron. Because reduction is talking about gain, while oxidation is talking about what? Loss. So a redox reaction, reduction is taking place and oxidation is taking place simultaneously. So when these two happen at the same time, then the reaction itself is called what? A redox what? Reaction. But take note, oxidation is loss of electron, while reduction is what? Gaining of electron. So if the reaction involves loss of electron is oxidation, and if the reaction involves gain of electron is what? Is reduction. Now let me show you something. copper and zinc 2 plus, to give us zinc plus copper 2 plus. So you trace this to zinc, you trace copper to copper. Now if you look at this, copper here is 0, zinc here is 0, right? Now if you are moving from copper 0 to copper 2 plus, is that loss of electron or gain of electron? Everybody look at it. If you are moving from this to copper 0 to copper 2 plus, are you losing electron or you are gaining electron? Yes. And if you are moving from zinc 2 plus to zinc 0, are you losing electron or you are gaining electron? Please, if you are moving from copper to copper 2 plus, you are losing 2 electrons. So if your loss of electron is what? Is oxidation. And zinc 2 plus, like copper, you gave out 2 electrons. Zinc has given out 2 electrons and you accepted 2 electrons again. The here is called what? Reduction. I know that most of you that don't understand redox reaction, you are confused. If the oxidation number increases, so increase in oxidation number is called oxidation, while decrease in oxidation number is called what? Reduction. So from 0 to +2, oxidation. From +2 to 0 is reduction. So if the oxidation number of the element increases, it's oxidation, and if the oxidation number of the element decreases, it is what? Reduction. Now look up. The substance which causes oxidation is called oxidizing agent. Now, what is oxidized here is copper. What causes copper to oxidize is zinc 2 plus. So zinc 2 plus is the oxidizing agent. So anything that causes you to oxidize is the oxidizing agent, and anything that causes you to reduce is the reducing agent. So copper is oxidized, zinc is reduced. Copper is the reducing agent, while zinc is the oxidizing what? Agent. So take note of that. God help me. Now, the reaction MnO4 minus plus I minus to give us MnO2 plus what? Plus I2. Now, in a situation like this, let me even trace this to this. Let me trace this to this. Now, it is very, very easy. It is very, very easy. What is the oxidation number of oxygen here? Oxygen is iodine here is 0. So if you are moving from -1 to 0, are you increasing or you are decreasing? You are increasing. So here is what? Oxidation. Yes, -1 to 0, you are increasing, and here is what? Is reduction. But in case you are confused, let me show you how to solve. The oxidation number of manganese here is manganese O2, right? So you solve for manganese. Manganese plus 2 times oxygen is -2 equals to 0. So that manganese here will give us -4, which is equals to what? +4, as I'm trying to use shortcuts. So if you have MnO4 minus, what's the value for manganese? Manganese will give us Mn plus, let's say -8 is equals to what? -1. So Mn is equals to -1 plus 8, which is Mn is equals to what? 7. So that means you move from 7 to what? To 4. So that means it is decreasing. And if it is decreasing is what? Reduction. And if it is increasing is what? Is oxidation. So now, but that's not what the question says. The question is saying the reaction, this can be balanced in basic medium producing dash. The reaction this can be balanced in basic medium producing dash. This is very, very useless question. The answer is what? OH minus. If it is basic, you are going to see this in your answer. But if it is acidic, the answer will be in what? In H plus. So any answer you see that is in H plus, it is acidic, and any answer that you see that is in that is in OH minus is what? Is basic. God. And we are still very much backward. So let me quickly move to the next concept, which is, now there's another question here before I move to the next topic. The law of conservation of matter, the law of conservation of energy, conservation of whatever, state that energy can neither be created nor destroyed, but can be converted from one form to what? To another, which is also known as the first law of what? Of thermodynamics. Take note of that. Then let's move to the next concept, which is chemical equilibrium. Chemical equilibrium. Now, chemical equilibrium doesn't mean the reaction has stopped. It means reactant is forming products and product is forming what? Reactant. And chemical equilibrium usually occurs in a closed system. But please take note, a system that allows the exchange of heat and material is called open. A system that allows the exchange of heat but no material is called closed. But a system that allows neither heat nor material is called what? An isolated system. Take note, anything that you can think of that allows the exchange of heat and material, like your open T, is an open system. But if, for example, what if you have something like your cooler is a closed system? What about a thermoflask? Is what? Is an isolated system because there is neither exchange of heat nor material. A very perfect example of an open system is the word cooler is a closed system, while a thermoflask, which is something you are going to see in your exam, is what? Is an isolated system. Now, chemical equilibrium is a state in which dash is correct. The answer is forward and backward reaction occurred at the same rate. Forward and backward reaction occur what? At the same rate. Now, when forward and backward reaction occur at the same rate, then we say the reaction is at what? Is at equilibrium. So that is the correct answer. Then the next one we have here, it seems that I've skipped. Okay, yeah, I'm on the right track. I didn't skip. Okay, I skipped some. I'll go back to it again. I skipped some. Now, for the reaction, listen, Na plus Nb, forward and backward reaction, Pc plus Qd, write the equilibrium constant. Please, if you have to write the equilibrium constant, which is K, it is very, very simple. You write product concentration of the product concentration all over what? The reactant, all over the reactant what? Concentration, which is K is equals to C raised to power Q, which is number of mole, D raised to power what? Q, sorry, raised to power P, all over what? A raised to power M, then B raised to the power of what? Of N. As easy as that. Let me show you another thing again. If you have something like N2 plus 3H2 forward and backward reaction to give us NH3. Yeah. If you have something like this, if they ask you what is the equilibrium reaction, so the answer will be what? K is equals to NH3, which is the product concentration, raised to power the number of mole, which is 2, all over nitrogen raised to power what? 1, then hydrogen raised to power what? 3. That is the equilibrium what? Constant. What if you have something like H2 plus O2 to give us what? HO. What's the equilibrium concentration? So if you write something like K is equals to what? H2O, yes, all over H2, all over what? O2, right? That is very, very wrong. Do you know why it is wrong? Because you cannot write an equilibrium concentration if the reaction is not at equilibrium. So for it to be an equilibrium concentration, there must be a forward reaction and there must be a what? A backward reaction, because they are going to occur at the same rate. Now please take note, for every equilibrium position, concentration can affect the position. Let me go deeper a bit. There is that which is called the Chatelier principle. The Chatelier principle states that if there is any alteration of the reaction by concentration, by pressure, by temperature, the equilibrium position will have to shift for another change. Let me explain. There are some bench you will be seated on. You will notice that if you shift to one side, the bench is going to bend, right? So if someone is seated with you, the bench will be at equilibrium. And if you want to get off from the bench, you have to tell the person that please adjust yourself so that you don't have to fall down, right? Now, what you are trying to do is Le Chatelier principle. Because as long as you getting up, you are going to affect the equilibrium position, the person will have to change his position to attain what? Stability. That is what Le Chatelier principle is talking about. And take note, catalyst can affect chemical reaction. Cannot affect chemical reaction, cannot affect equilibrium position. Catalyst can only speed up the rate or slow down the rate. So catalyst affect the rate of the chemical reaction. Catalyst does not affect the equilibrium position. Catalyst does not affect chemical reaction, but catalyst affect the rate of the chemical what? Reaction. Another thing again is that if they ask you what is the effect of catalyst in equilibrium reaction, it also actually have an effect. The effect is that it will speed up the rate of forward and backward reaction. It will not only speed up the rate of forward, it has to speed up the rate of forward reaction and that of what? Of backward reaction. Yes. The next one here, If nitrogen reacts with 3 hydrogen, forward and backward reaction to give us what? NH3. If you increase the pressure, where will the equilibrium concentration, where will the equilibrium position shift to? If I increase the pressure, where will it shift to? Please, first of all, make sure, if they ask you, can pressure affect this equilibrium reaction? The answer is yes. Do you know why? Because all of them are gases. If all of them are gases, that means it can be affected by what? It can be affected by what? Remind me now, by pressure. So, how many number of moles do you have here? 1 plus 3 will give us what? 4. Here will give us what? 2. So, which side has less number of moles? The answer is what? Is NH2. So, as long as NH2 has lesser number of moles, the equilibrium position will have to shift to the side of what? Of NH2. That means more ammonia will be formed. So, it's going to favor the what? The forward reaction. So, if any equilibrium reaction, let me show you something. For example, if you have something like A2 plus B2 to give us 3C, here is gas, here is gas, here is gas. As long as all of them are gases, the equilibrium position will be affected. Now, how many number of moles do you have here? Is 2. How many forward and backward reaction, please? How many equilibrium reactions do you have here? How many number of moles do you have here? Is 3. So where will it shift to? Is it going to shift to C, or is it going to shift to the reactant? Is it going to shift to the where? To the reactant, because it is 3. So if it is like this, it will shift to this side to attain stability. And if it is like this, it's going to shift to this side to attain what? Stability. So it's going to shift to the side that has lesser number of moles for stability to be what? To be attained. That is for that. Chemical combination, I skip chemical combination. So let me quickly go back to chemical combination. Now, there are 2 major types of chemical combination or chemical reaction, which is covalent and what? Electrovalent. So, electrovalent is also known as ionic. So, those are the 2 major types of what? Of chemical combination. But there are some few things I want you to take note of in chemical combination. I hope my network, okay, it's not the network issue is not for me. Please, if you have any question, I'll try to be very slow. And please, and please, I want to encourage every one of us here. I'm not going to explain anything I've explained in this class in Casio-Rema. I'll be live in Casio-Rema. Please take note of that. But what I've explained here, you will not see it in Rema. We have chemistry is very, very broad. So we have other things I'm going to explain in Rema. All of them are still going to come out in your exam. Everything is going to come out in your exam. What I've explained here, it will always be here. And what I will explain there, it will always be there. So please, try as much as possible to catch up. And how many minutes? Let me, oh God, we are already out of time. Very out of. Now, I told you that we have possible examination question on CHM 101, and it covers how many topics? Let me check if you can see it clearly. Okay, light issue. It covers 15 topics. Right from thermodynamics, properties of gases, historical development of atom, periodic table, electronic configuration, hybridization, chemical kinetics, chemical bonding, chemical reaction, chemical equilibrium, acid, base, and salt, radionuclear chemistry, structure of solid, atomic spectrum, and electrolysis. Now, this material is only available for just 1,000 naira. You are not getting the hard copy. What you are getting is what? The soft copy. So for those persons who are interested, you can go to our group chat. So I will update you later on that. So the material is currently available now, and payment can start as from today till on Wednesday. Payment end on Wednesday, and after on Wednesday you cannot get this material again. So please, for those persons who are interested, make sure you send us a DM at 081-2023-9539. That is just the truth. So you can get the material there. And let me check how many questions do we have here. We have about 500 plus questions. We have 500 plus questions on this material. 500 plus questions. Don't forget, if you are not a subscriber of this YouTube channel, please do well to subscribe So let's continue with our class. We still have a lot of things to cover, because anywhere we stop, it ends there. I'm not sure I'm going to continue with this life again. Now, in an exothermic reaction, increase the temperature, please. Exothermic reaction, if you increase the temperature, if the reaction, if I say exothermic, it means the reaction is negative. If it is, the enthalpy is negative. If it is endo, the enthalpy is what? Is positive. Exo, it gives out heat to the surrounding. Exo, it absorbs heat to the what? To the surrounding. So this is what I want you to take note of. For an exothermic reaction, if you increase the temperature, for an exo, if you increase the temperature, it will shift. For an exo, if you increase the temperature, it will shift backward. And for an endo, if you increase the temperature, it will shift what? Forward. Now, that means I said if you increase, it will favor the backward reaction. That's for an exothermic. Then for an endothermic, if you increase, it will favor the what? The forward reaction. Now, another thing again you should take note of is that if you should not decrease the temperature, what will happen here? This arrow will face the other side. And if you should decrease the temperature, what will happen here? This arrow will do what? Will face this side. So take note. Increase in temperature first of all, for an exothermic, which is if the energy is given out to the surrounding, which is loss of energy, if you increase the temperature, it will favor the reactant, and if you decrease the temperature, it will favor the product. While for an endothermic, if you increase the temperature, it will favor the reactant, and if you decrease the temperature, it will favor the what? The product. So that's something I want you to take note of. And let me quickly explain concentration. If you increase the concentration, it will favor the forward reaction. And if you decrease the concentration, it favors the what? The backward reaction. So if you increase the concentration of the reactant, so that's what I mean, it will favor the forward reaction. If you decrease the concentration of the reactant, it will favor the what? The backward reaction. And if you increase the concentration of the concentration of this one, it will favor this one. If you increase the concentration of this one, it will favor this one. If you increase the concentration of the reactant, it will favor the product. If you increase the concentration of the product, it will favor the what? The reactant. So that's what you do. But if you decrease the concentration of the reactant, it will favor the reactant. If you decrease the concentration of the product, it will favor the what? The product. Let's go again. Increase reactant favors product. Increase product favors reactant. Decrease reactant favors reactant. Decrease product favors what? Product. That is all for chemical what? Equilibrium. Yes. So we have like 17 minutes more. So let me see what we can do with that 17 minutes. Ah, God, I still have a lot of things to do. Now, which of the following is monobasic? Which of the following is monobasic? There's that which is called basicity of an acid. Now, let me quickly explain what basicity of an acid means. Basicity of an acid is the ability of an acid to lose its proton, or the ionizable part of hydrogen ion of an acid is called basicity. I know that I'm very, very fast. Let me go slow and steady. Basicity of an acid talks about the number of replaceable hydrogen ion of an acid. For example, if you have H2SO4, the basicity of this acid is what? 2H plus what? SO4, 2 minus. If you have hydrogen chloride, the basicity is what? H plus what? Cl minus. If you have HNO3, the basicity is what? H plus what? NO3 what? Minus. If you have CH3, COOH. Now, if you have anything that is COOH, it's an organic acid. And the basis of an acid is H plus what? CH3, COO minus. Now take this from me. All organic acid, anywhere you see COOH, all organic acid are monobasic and they are weak acid. I repeat, all organic acid, first of all, they are monobasic and they are what? They are weak acid. Now, how many replaceable hydrogen ions do you have here? Is 2. So it is what? Dibasic. 1. Monobasic. 1. Monobasic. If you have H3, PO4 will give us what? 3H plus what? PO4, 3 minus. Now, this is what? tribasic. If the replaceable hydrogen ion is 1, monobasic 2, dibasic 3, tribasic. All organic acid are monobasic, and all of them are what? Are weak acid. So take note of that. Which of the following is an organic acid? Which of the following is an organic acid? Option A, we have HCl. Option B, we have CH, C2, H5, COOH. Option C, we have let me check. We have HNO3. Option D, we have sulfuric acid. Now, someone will see sulfuric acid and be like, this is the correct answer. You have just failed it. I told you, when you see anything like COOH, is what? An organic acid. An organic acid, they are what? They are weak acid. Look at this one too. So both of them are organic acid. This is ethanoic acid and this is propanoic acid. Or propionic acid or acetic acid. So take note of that. Strong acid are those that ionizes completely in water. So any acid that has the ability to ionize completely in water is called what? Is a strong acid. So take note of that. Then, which is that one? Which is that one again? And also acid consists of dash. Now, also acids consist of hydrogen, oxygen, and any other element. Usually sulfur, nitrogen, and what? And carbon. So anything you see like this is an also acid. And the element which is sulfur, nitrogen, or carbon is usually the center. Is usually the center. So they are also acid. For example, if you have H2SO4, consists of sulfur, oxygen, and what? Hydrogen. Is an also acid. If you have H2CO3, carbon, oxygen, and nitrogen, also acid. If you have something like HCl, is there any oxygen there? No. So it's not a what? An also acid. If you have sodium hydroxide, is there oxygen there? Yes. Is there hydrogen there? Yes. But is this hydrogen an acid? No. So this is not an also what? Acid. And also acid, this hydrogen is usually as an acid, not as a hydroxy. So take note of that. And this element here is usually a non-metal, can never be a metal. So this element is a metal, which means it is what? It is a hydroxide. So take note of that. Then another thing again I want to take note of is, very good, is salt. Salt. Now, when a strong acid reacts to a strong base, it will form a normal salt. Because both of them have equivalent power, right? So the salt will be normal. But if the acid is stronger than that of the base, that means if you have, let's say, sodium SO4, this is the normal salt. But because the acid is stronger than the base, which is stronger than the weak base, you are going to form sodium hydrogen SO4. So this is what? Acidic salt. But if the base is stronger, you now have something like, let's say, sodium hydroxy SO4. I'm just trying to, but this compound is not correct, but I'm just trying to give you something like this. So this is what? A basic compound, a basic salt. Acid salt consists of hydrogen, basic salt consists of what? OH. Normal salt, there is nothing there. Complete neutralization. But there are some, there is that which is called double salt. Now, a double salt consists of 2 cations and 1 anion. For example, potassium aluminium SO4 sulfate. Let's say here should be, I don't know if here should be 3, but let's leave it like this. I can't really recall. But potassium is positive, aluminium is positive, then SO4 is what? Is negative. So if you have something like this, you have 2 cations and 1 anion. So this is what we call a double salt. If you have 2 cations, let's say, let me give you another one again. Let's say Fe, sodium Fe, let's say SO4, assuming there's a compound like this. Now, this is a cation, this is a cation, this is an anion. Now, if you have something like NaOH SO4, this is anion, and this is cation. So it is not a double salt. And this anion here is hydroxy, so it is basic. So if you have 2 cations and 1 anion, it is what? A double salt. Then if the salt is written in this coordination sphere, if you have any compound that is written in here, so it is called complex. So it is a what? A complex what? Salt. So take note of that. So acid salt has hydrogen, basic salt has hydroxy, double salt has 2 cations and 1 anion, while a complex salt is written in what? In a coordination sphere. Then that's for that. A substance which produces hydroxy when dissolved in water is called what? Base. It's called what? A base. While the one that produces hydrogen when dissolved in water is called what? An acid. and acid. We have just 5 minutes to the end of life. So I might not be able to finish everything as planned, but we have actually tried. We have actually tried. So the last concept I'm going to explain here is atomic spectrum. Is atomic spectrum. Is the atomic what? Spectrum. Now, for the atomic spectrum, when hydrogen, the first question here, now there are different kind of atomic spectrum. The first one we have there is the Lyman, we have the Balmer, we have the Paschen, we have the bracket, we have the Fond. Now, for Lyman is 1, here is 2, here is 3, the value of N is 4, here is what? Is 5. Lyman, it is ultraviolent. It is found in the ultraviolent region. Balmer is found in the visible region. Paschen is found in the infrared. Bracket, infrared. Then here is what? Infrared. Now, they will not ask you which of them is found in the visible region. They will not ask which of them is found in the ultraviolet. The question will be, which of the following series is visible to the human eye? Is visible to the human eye? The answer is what? Balmer, which is what? Found in the visible what? Vision. Very, very cheap. Another question again is that when an atom jumps from a lower energy to a higher energy, what happens? It means it has absorbed energy. For it to move from a lower energy to a higher energy, you have to absorb energy. So it is because they have absorbed what? Energy. Number next, the transition produce. Which transition produce a what? A Balmer line. Now, which transition produce a Balmer line? Let me write the option so that you understand very well. Now, option A, N2 is equal to 2. Then, so N1 is equal to 1. Option B, we have N2 is equal to 4. So N1 is equal to 3. Option C, we have N2 is equal to 3. So N1 is equal to 2. Then option D, we have N2 is equal to 5. So N1 is equal to what? 4. Now, which of the transition produces what? Balmer. Now, remember, we are talking about the Gido approach. This operation, look at click. What you do is that, what is the value of Balmer? 2. Look at this part. Which of them is 2? This one. That's the answer. So you don't even need to look at from this to no. Where is it? Which of them is in 2? Because we are talking about the transition. So you are transiting from one to another. And where are you transiting to? You are transiting to what? To 2. So if you check your answer, which of them is 2? That will be your what? Your answer. So you can move from 5 to 2. You can move from 1 to 2. You can move from P4 to Paschen. You can move from P4 to bracket. You can move from Paschen to this. You can move from this to this. You can move from this to this. But for you to move from one energy level to another energy level, you must have to absorb energy for that transition to do what? To take place. Then the next question here. When electrons jump from the fifth to the higher energy level, from the fifth to the third energy level. Sorry, when the electron jump from the fifth to any higher energy level or to the third energy level, which is you are jumping from this one, fifth, to which one again? From the fifth to any higher energy. Sorry, when electrons jump from the fifth or any, so fifth or any higher energy level to the third energy level, Where is the third energy level? This. So what is this? Is fifth to Paschen, from fourth to this. So wherever they jump, please take note. The N1 must be greater than the N2. Sorry, the N2 must be greater than the N1. So you can jump from this to this, can jump from this to this, can jump from this to this. So please take note of that. And that jumping can only occur when you absorb what? Energy. Then let me check the time. Oh God, it is exactly 10 o'clock. But before we go, finally, I want to show you something really quick. Now, there is this thing again I've seen in most of your exam, ClO4. Now, what is the oxidation number of chlorine? First of all, this minus here is a radical, so you write Cl plus O4 is equal to what? -1, because it's a radical. So you write chlorine plus 4 times what? Oxidation number of chlorine is -2. which is -1. Chlorine minus 8 is equal to -1. Then chlorine is equal to what? 8 minus 1. And chlorine is equal to what? Is 7. So the oxidation number of chlorine is what? Is 7. That is under electrolysis. And please take note. Electrolysis uses chemical reaction to produce electricity. Electrolysis uses chemical reaction to produce what? Electricity. That's something you should take note of. And like what I said, electrolysis has three important laws. Three important laws. The first one is the Ohm's law. The second one is the Faraday's law. I believe Faraday is very, very popular. While the next one is what? Corrash's law. So these are the three laws of what? Of electrolysis. Ohm's law, Faraday's law, and what? Corrash's what? Law. Now, there are three things that are very, very important in the preferential discharge of electron. Now, once we have two electrodes or two cathodes. Now, once we have two electrodes or two cathodes, there are some things I want you to take note of. And there are some things I want you to take note of. And those things affect the selection of ions. For example, let's say we have sodium plus and we have copper 2 plus. Which of them will be discharged at the cathode? Because this is the electrolytic cell. Let me close with this. Now, this is the electrolytic cell. This is the electrolytic cell. So this is, now, here is minus, it will go to the minus, here is plus. I hope I'm correct, it will go to the plus. Now, minus is now, these two poles, we call them the electrode. The electrode that is negatively charged, is called the cathode. The electrode that is positively charged is called the what? The anode. Now, if, for example, you have OH and you have chlorine, you have sodium and you have copper. Now, in this case, copper that are positive, or these elements that are positive, will be attracted to the electron that is what? The anode, the electron that is what? That is negative. Positive ions, we attract negative cathode. So they are called cathode ion. For sure, we call them cation. And negative ions, we attract positive electrode. So because they are going to attract positive electrode, we call them what? Anode. And that's what they call what? Anion, anode ion, anion. And there's something we are going to take note of again. CRAM. In the cathode, reduction takes place, while at the anode, oxidation takes place. I repeat, cathode reduction, anode what? Oxidation. There is that thing again. If they ask you what happened at the cathode is reduction, while what happened at the anode is what? Is oxidation. So cathode is reduced, while anode is what? Is oxidized. Another thing again I want you to take note of, we have the oil rig. Oil rig means oxidation is loss of electron, while reduction is what? Gaining of electron. So whenever you lose electron is oxidation, and whenever you gain electron is what? Is reduction. So there are three laws that affect the preferential discharge of electron, which is selective discharge. When you have two ions like this, there are three laws that govern that. The first one is the concentration of the ion, the position of the ion is the electrochemical series, which is the position. That's why we said, Lobel, please stop consulting me as PG. That is the electropositivity series. Or for the natural fire, which is the electronegative. I don't want to go through all of those things again. Now, the ones that are higher and the ones that are lower, the ones that are higher are more electropositive than the ones that are lower. So therefore, the ones that are lower will be preferentially discharged. That is for the position. But for the concentration, the one that is more concentrated will be discharged. That is for the concentration. That's if they are close. Therefore, the nature of electrode, there are some electrodes that prefer some electrons. There are some electrodes that prefer some ions. So that's just for that. There are three laws. The first one is the position. The second one is the concentration. While the last one is what? Is the nature of electrode. Don't forget, no speed, no catalyst, rather, no speed. And I want you to take note of this. The material is already available for those persons who are interested. From what I've given to you so far, I believe that at least, we have covered a lot of things in chemistry, and what I was doing then, I will pick one question and use that one question to explain other questions. So we have actually covered a lot within these 2 hours. And this material is already available officially, and the price is just 1,000 naira. How many topics we have here? 15 topics and 500 plus question. Please, if you have any friend that is not in the live stream, tell the person to come back to this video now before this video is officially deleted. Good night, everyone. I wish you all success in your exam. And don't forget, remember our continues at Casio Community Tutorial. I'll be there on Monday, back to back. And the chemistry which is session 101 will be strictly based on the Gido approach to chemistry. That's strictly what you are going to do. Operation look and click. You look at the answer, you click on the answer, then we'll move on. Thank you very much, and I hope to see you all. Please just give me at least 90 in your exam. Just give me 90 in your exam. If you can give me that, I will be very, very grateful. Good night, everyone. I wish you all success in your examination.